Thank you for your presentation. I will show something about my institute. I come from CNR ITA in Messina. CNR, as you know, is the most important research institute in Italy. It has a lot of several institute in all the country, and with different topic that are researched in various institutes. In our institute, the main mission regards energy system, the development of new devices and energy system that are have a low impact on environment, that are efficient, that not use common fossil fuel, and so on. The main actors inside the institute are chemists and engineer, but also other expertise are present in institute regarding modeling, analysis of system, realization of studies of social life, life cycle assessment, and so on. Considering my working group is a big working group because it has also chemists and engineer inside its structure. So we start from device developing, so choosing new materials or testing new materials, to test, to integration of this kind of system in energy system, and also in realization of other new energy device and new energy technologies. The field in which we operate are obviously all the field related to energy, starting from transportation, going to smart building, to smart grid, and so on. So in our institute, we have a lot of also test machinery for testing, for example, of batteries, but also an important component of the institute are fuel cell and hydrogen. So the institute has a lot of skill regarding hydrogen, development of hydrogen-related devices, both in production of hydrogen and utilization of hydrogen, so electrolytes and fuel cell. Okay. Some as Pinar asked to me, I will show in the previous slide, in the first slide, something regarding the state of art of energy storage and energy storage utilization inside off-grid context. You know that energy storage is probably the most important research topic in energy at the moment, because the flexibility, some features that energy storage can bring to the grid in stationary sector, but not only, also in the transportation sector and in other sector, is very important. A lot of features can be guaranteed by energy storage because they offer flexibility, reliability, and in particular in the case of grid context, they enhance the power quality of the system. As you know, probably better than me, there are different kind of technologies and different kind of mechanisms that can be used to store energy, such as thermal, mechanical, chemical, and electrochemical. And a lot of technologies were developed in recent years, considering all possible mechanisms and also hybridization of different mechanisms. You know that to identify some performance of the energy storage system, normally a Ragone plot was used, in which energy and power density expressed in watt or watt hour per liter or per kilogram is used, and it is useful to see in which part of this kind of Ragone plot the technology can be located. If you have to manage a more specific power-oriented technology or an energy one. Obviously, the holy grail of the energy storage is to reach high specific power and high energy, a specific energy. So the top right part of the Ragone plot, it is not the only aspect that you have to consider when you speak about energy, because another important aspect are costs, obviously, and the presence of material that are abundant and useful for energy storage. But this is an important aspect in the energy storage. So the ability to have system able to reach high specific power and contemporary high specific energy. This is the reason for why hybridization is important, because sometimes, often, you have energy device intensive or power intensive device, and combining them, you can reach the top left right part of the Ragone plot. This is a summary of possible technology, considering all possible mechanism of energy storage. And the graph on the right show exactly what I said before. The goal that you have to reach to perform almost the possible application that you can. You see that for each mechanism, a lot of different technology are developed in recent years, and new other technologies are continuously studied by researchers in over the world. My institute in particular is focused on electrochemical device. So what I will show now is important of the energy storage in general, but also of the electrochemical part. Considering the grid sector and the stationary sector, okay, the most important energy storage technology in terms of diffusion, in terms of power installed, is pumped hydro, obviously, because we are speaking about gigawatt of installed capacity. But considering the other technology, electrochemical one are becoming more and more important due to the flexibility and the modularity that they offer to the market. And one of them, lithium-ion, probably carried out by the transportation sector that as in recent year is using this kind of technology a lot, is becoming important in this context. The table summarizes some of the most important features when you consider energy storage, that are obviously the power range, the discharge time, the power density, the energy density, the efficiency, the lifetime, and cycling capacity. So when you compare different technology, these are the aspect that you have to consider. Also costs is not present here, but these are the main aspect that you have to consider when you have to design and select an energy storage system for the application. This is the trend that you easily can find in literature regarding electrochemical storage in installation, and as you can see, it has an exponential growth in recent years. For example, over 40 gigawatt were installed in only 2023. That is about twice what happened in 2022. Considering the market of stationary application, you know that the two possible application can be considered, and three, if you see also the topic of the presentation, that are utility scale and behind the meter. So in front the meter and behind the meter. The meter represent where the storage system is installed in the connection of the storage system in the grid. Obviously, the most part of the installation regard the utility scale, because at this scale you consider installation of various order of magnitude than behind the meter application, but also behind the meter application with diffused renewable energy sources are becoming important. Okay, a brief, I will go very quickly in this part, considering some of the electrochemical energy storage, but only to give you some spots regarding each kind of technology. These are probably the oldest one in terms of electrochemical aspect for the energy storage, and are lead acid and nickel cadmium nickel metal hydride. Lead acid are today also important. For example, considering the vehicle, currently the starter battery of the vehicle is lead acid, because the lead acid offer, for example, performance interesting at very low temperature. When you have to start your vehicle and you want to use, for example, lithium, it can give you some problem, because the lithium has not the same performance at low temperature as lead acid. Also, they have some other benefits, such as low capital cost, low maintenance, high power release. But the main problem with them regarding the use of lead, obviously, the high self-discharge, the weight also is important for lead acid, and so on. For nickel, nickel also is an important technology. In particular, it was the first technology used in the transportation sector for traction. Okay, before lithium batteries, because it has a superior performance of lead acid in terms of specific energy and specific power, but the use of cadmium was a problem. This was substituted by metal hydride that offer generally interesting performance, but the problem of high self-discharge and a low Coulombic efficiency when they are fast charged, okay, is an important aspect that limited them in this sector. But the main issue is that lithium overcome this kind of technology in all of the aspects that we considered before. Two other kind of technology are sodium-based. Sodium-based can be divided into high temperature and low temperature. High temperature have two main important technology that are sodium sulfur and sodium metal hydride. For example, sodium nickel chloride is a technology. These are good batteries in stationary sector, because they offer high power and energy density, high efficiency, high life cycle, low cost potential. The main issue regarding the fact that they works at 300 degree, so they needs heater to work, and this reduce obviously some of the energy that is used by the battery, and so lower the round trip efficiency. Sodium ion are recently appeared to the market, and probably can constitute the technology that can substitute the lithium, because the mechanism is quite the same, is the intercalation, but sodium is more abundant and have no some of the issue of the lithium batteries. But at the moment they are at the research lab. Some commercial product appears to the market, but they are at the industrial chain is still incomplete, and also the short life cycle at the moment is a problem. So researchers are working on this kind of technology. Also in our institute, we work on the realization of new kind of sodium-ion battery, but this is an very interesting technology. Okay, we arrive also to the main technology regarding batteries that are lithium-ion. Lithium-ion battery are a world, because several technologies inside lithium-ion were developed, considering different combination of cathode and anode. Also for cathode, there are different kind of possibilities, and the name of each cathode or anode used give the name also to the technology. This graph that are normally used to compare technology that are in which all the figures appears, compare the different kind of technologies. So for lithium batteries are very important, because they offer good energy density, good specific energy, long lifetime at the moment for some technologies, such as lithium iron phosphate or lithium titanate, high DOD of use. They become in recent year the most important electrochemical technology. the main risk, the main issue regarding them is related to safety issue, as you know, because the phenomena called thermal runaway can happen if you have an uncontrolled increase of the temperature inside the battery. And the second one regards the use of critical raw material. Cobalt, also nickel, also lithium are materials that represents are in the list of critical raw materials, and they probably in years this can become a problem, because the supply of this material could be a problem for the request that the market need. Another important technology regards totally different from the battery that we have explained before, is considered by the flow batteries. Flow batteries are divided in two main categories. One are redox flow battery and one are hybrid flow batteries. Redox flow battery, for example, are vanadium or polysulfide bromide, while hybrid flow battery are zinc bromide. The difference is that in the case of the hybrid flow battery, the electroactive material is not only in the electrolyte. In one side is in the electrolyte, but on the other side, the behavior is like normal battery ones, so is the electrode, okay? But the behavior is quite the same. The main these kind of battery are very important, I think, in the stationary sector, because they probably cannot be used in other contexts, for example, in transportation. But without the limitation of space use, you know that the energy depends on the size of the tank, while the power depends on the size of the stack. So they can be designed for the decided application in the way you want, and they offer good performance. The main issue regarding them is obviously the round trip efficiency that is lower than other kind of technologies. Another important electrochemical technology is considered by supercapacitor. Supercapacitor are important only for power aspect, because you know that energy retention is very poor for this kind of technology, but the power that they can release is can reach value that other technology can't reach in any way. There are also inside supercapacitor different kind of technologies depending on the mechanism. I said before electrochemical, because in case of double layer supercapacitor, you have electric behavior, because it is related. There are no reaction involved in this case. But in the case of pseudocapacitor and hybrid supercapacitor, there are fast redox reaction involved, or also intercalation mechanism like batteries, but differently from the batteries. They are fast mechanisms that do not involve phase transition at the electrode. So the importance of this kind of device is related to the rapidity on which they can act, and the capability to give high pulse of energy in a few seconds. Lastly, another important electrochemical technology, probably the most complicated one, but probably the technology that can have a future in different aspects, is hydrogen. Hydrogen can become a storage system when you consider all the chain. So production coming from green sources, electrolyzer to produce hydrogen, tank storage at pressure to store the hydrogen, and fuel cell to release energy. So it is a complex system, and obviously the main problem regarding hydrogen is costs. But considering this chain, it can provide easily an increase in the energy environment effect, okay? And also here, different kind of technology are developed, considering the mechanism that can produce electricity starting from hydrogen. Another problem regarding this fact is that obviously in this chain, the efficiency of the whole system is low. But hydrogen, it can be a solution differently from batteries, because hydrogen can provide also long storage, for example, seasonal storage, and energy. Hydrogen has to be considered more a vector of energy than energy itself, but it can have, due to production, due to industrial development, increase in some performance, and also a very important future next years. Going to hybridization, the main categorization that normally is done regards near term or long term, depending on the ability to release energy for small or longer time, and different kind of possible combination, as you know, are useful, depending also on the application and on the scope that we have. The scope also is to reach, as I underlined before, an higher level. Normally, hybridization is done by the use of an energy-intensive device and a power-intensive device to reach an higher level in the Ragone plot. However, also, hybridization can be useful to prolong the battery system, because if you have one system that have to do different kind of application, and you can split in hybridized mode some task to the two system, you can prolong the battery of the lifetime of the whole battery, because some of them are more skilled and more. For example, if you consider supercapacitor are very skilled to provide power and can do this in thousands and thousands of cycles. If you ask this to another battery such as lead acid or lithium, they can do this, but it has an important impact on the degradation aspect. Okay, also in considering hybridization, different possible topologies of integration. So the thing that you have to consider is that complexity of the system obviously increase, because you have to consider the integration of system by power electronics, and different kind of topologies can be used to do this. And also the complexity regard the management of the system. Normally, it is done by two-level architecture, one that is directly connected to the single battery, and one that is an upper layer called normally EMS, Energy Management System, that has the task to optimize the use of the battery. So going to the task of this presentation, off-grid, weak-grid, and island represent a part of the stationary sector. Off-grid generally are considered electricity systems that are able to supply energy inside a sort of micro smart grid, without the need to be connected to the main grid. In fact, they are not only rural or remote area, but also systems that can perform intentional islanding for some reason, for example, to increase their revenue or to obtain some internal goals of the microgrid. A weak grid is a grid that has the characteristic of an off-grid system, but also due to the power and energy involved, have some problem to maintain voltage and frequency. Okay, that are the two parameters that you have to maintain in a certain range to provide to supply your devices. And a weak grid has some issue regarding the maintenance of the values inside this working range, and need the help of energy storage to do this, because sometimes there is an imbalance. Often there is an imbalance between production and request, and this can be solved by the use of a buffer such as energy storage. Mini grid and microgrid are common definition regarding the sides and are systems that can operate independently or in conjunction to the grid, serving it with some possible services. These you can find some numbers that are retrieved from literature regarding the off-grid context. Currently in the world, there are about 700 million of people that live without electricity, and the most part of them is located in the sub-Saharan area. This number probably cannot decrease a lot in 2030, so it remain an important problem to serve and to provide electricity to this part of the world. Also, in this context of off-grid, also the small island represent an important users that needs energy system. More of the grid part of them is located in Pacific, but in European island, about 500 of the island can be considered small island or isolated island. Also, mini grid, as the definition of before, are about 21,000, but we expect to increase this number a lot in 2030, considering a number of one order of magnitude increased. In this case, we consider all possible grid that are able to perform intentional islanding for internal scope. This is a brief review of the service that battery can provide to the grid, and as you can see, a lot of these services are very important to maintain the stability of the grid. The most important thing to do here is that the access to the market of the services is currently in developing, and several countries are studying how batteries can provide this kind of services in a distributed way to the main grid, because the main grid are not thinked to accept renewable energy sources in more and more grew in years, and also in a storage system, because they are thinking in a centralized way and not in a distributed one. In off-grid context in particular, they can perform different tasks. Probably these one are the most important ones, such as reduce the generator usage, do arbitrage of energy when in off peak or in peak moment, reduce demand charge, reduce the interconnection, increase the power quality, do backup, and supply uninterrupted power critical loads. So the importance of the energy storage in this context is highlighted here. This is a state of art that I retrieved from literature of some of the small islands, okay, in which you can find energy storage system, and I underline it in red, where some sort of hybridization is done, okay, considering, for example, power pumped storage and batteries, or fuel cell and batteries, or supercapacitor and batteries. So possible integration of system. Okay. So as you noticed, the storage system are very important also in this context, because the increase in the use of renewable energy sources has to be supported by energy storage. This one is, I will show now two different use cases, one with hybridization and one with no hybridization. This is the case without hybridization. This is a regional project in which we were called to provide the storage system in 3 different islands, Ustica, Favignana, and Lipari, with different issues. And the main goal of the project are the realization of a techno-economic analysis of the system, the design and the creation of the storage system, and also the management of the storage system inside the grid of the island. The main issue that you have in this context are the renewable energy sources and their randomness, because this create mismatch between load and production. The instability of the grid, because it is not the main grid, so the power involved are less than those involved in main grid, and this can create instability. The quality of the surfaces, the safety issues regarding the absence of electricity in some cases, but also in this context, also landscape constraints are important, because you can't install energy storage where you want, but in point in which it is possible. So the idea behind is to realize the system to perform real-time monitoring and integration with intelligent interaction, and use load and generation forecasting in this context. For the case of Favignana, but also in the other case, as we will show, a distributed system using lithium iron phosphide technology is realized. Lithium iron phosphide is chosen after an analysis of different possible technologies, because probably among the lithium batteries the safest one, and offer good C rate, good performance in general. Considering the other technology, the main difference is that probably the specific energy is less than the other one, because in this case the cathode used has a cell voltage that is inferior than the other one. To overcome the issue regarding the secondary substate, the landscape constraint, we installed this kind of distributed storage in the secondary substation, so close to the main grid. In the case of Lipari and also Ustica, another problem comes that regards the desalinator. Desalinator is probably the most important load in the island, and we installed also a storage system here and provide also an innovative system to recover energy from the water that comes from the desalinator, so in an integrated system inside this context. The work done by us in the project was the testing of the selection and testing of the device selected for energy storage. The custom electronics was realized inside the project by a Sicilian company to integrate the energy storage system, and also SCADA system was realized to manage the distributed energy storage in the island. Okay, the case with hybridization is an European project that is currently ongoing. Last 2 weeks I was in Sevilla to perform tests about this system, and consider the integration of 2 different systems. One is the lithium technology, probably the best one considering lifetime, that is a lithium titanate oxide, and an innovative redox flow battery produced by a company that is inside the project, is Chemivat, that is an aqueous organic redox flow battery. This kind of battery is interesting because do not use toxic material, such as the case of vanadium 1, and has some advantage in terms of lifetime, also in realization, and we are testing this kind of technology inside the project. The main goal of the project are the realization of the hybridization, but also to maintain some KPI, such as round trip efficiency above 90% for LTO and 75% of AOFB, the reduction of CAPEX and OPEX, to maintain the energy storage cost below a threshold, and to replicate this kind in at least 3 demo sites. These are the 2 main technologies, okay? The system that we used, and in terms of energy and specific in terms of energy installed and power that can release at maximum, the LTO is considered the power part of the system because it is able to reach 3C of power released, while the aqueous organic redox flow is considered the energy part of the system. These are pictures that I took the last week when I was in Sevilla, because the system at the moment is being integrated in a container that will arrive to the first demo site that is in Messina at the end of this month. These are the inverter that were used and the system that were used to integrate in terms of power electronics. This is the architecture chosen in a certain sense because the part regarding the redox flow battery is realized by Chemivat. We realized inside the project the custom inverter that is able to do islanding. So the integration is done with power electronics and also with energy management system. These are the 3 sites in which the system will be installed, one in Messina, one in Belgium, and one in Netherlands. Different use case. One is a redevelopment project of a small degraded area in Messina. The other one is energy communities, and the third one is a small medium enterprise. This is how the system integrates. You can find here the 2-level architecture. One that is related to the connection to the 2 system, and one at the cloud level that is the energy management system. This is what we want to perform in demo site, or the different services provided by the battery inside the context in which they will be installed. As you can see, island operation is one of the possibilities that we can perform. We decided the part of the 2 technology that have to intervene in each of these services, and we will test this probably next month in Messina. Some tests that comes from the last week that I was in Sevilla. As you can see, here some tests were performed to do cycling, to give set point to each system, and also to see the behavior at pulses or when we stop and so on. So we are at the moment in the development phase of the hybridization. As you can see, the lithium titanate is able to release high power. The aqueous organic redox flow that we tested is not the final version, because at the moment we worked with a diluted electrolyte. When the system will come to Messina, the tank will be filled with an improved version of the electrolyte. That is a proprietary electrolyte. We know something about this, but is a research project. But considering that we have a company involved inside the project, some things are not known. The final slide is not my skill, but is a study performed by Lomartov, that is one partner of the project, regarding the preliminary evaluation of the LCOS of the system. This is the formula used for the evaluation of the LCOS, in which you can find CAPEX, OPEX, and also the price related to purchasing of electricity. These are the value that were used inside the simulation, and the final table show a comparison with the state of art of hybridization. As you know, the price of energy depends on which kind of energy you use to store and release energy. So a sort of sensitivity analysis was done inside the work. You can find the whole deliverable with the study at this link with 0 and 100%. As we expected, considering the optimization of the system, so 15% reduction of the capex and 13% of reduction of operation and maintenance cost, we reached in a way that has to be validated in demo site, good LCOS compared to other systems. Okay, thank you.